Hi, this is Olajide from CTF Security and welcome to day 22 of TryAcme Advent of Cyber 2023. In today's video, we'll be exploiting server-side request forgery, commonly referred to as SSRF. We'll learn about different types of SSRF, the prerequisite for exploitation, and some helpful tips on how to safeguard against SSRF. We'll use our SSRF skills to assist Detective Frost in taking down a command and control server. So without further ado, let's get started. Hello and welcome back to today's SSRF task. And as you can see, the tagline for today is Jingle Your SSRF Bells, a merry command and control hack venture. Now, if you take a look at the right corner of the screen, we have our Start Machine button, which I'm going to click, and it is going to take approximately 2 to 3 minutes for this machine to fully load. So while it continues to load, let's use that opportunity to go through our storyline for this task. And it goes this way. As the helps try to recover the compromised server, Mark Skiddy's SOC team identify abnormal traffic and notice that a massive amount of data is being sent to an unknown server. This is talking about the command and control server we discovered in day 9 of the Advent of Cyber. An insider has likely created a malicious backdoor. Mark Skiddy has contacted Detective Frost from law enforcement to help them. Can you assist Detective Frost in taking down the command and control server? Now we have the learning objective for this task. I'm not going to be going through that because it has actually been covered during the introductory part of this video. So we're going to dive straight into what an SSRF is. An SSRF is a security vulnerability that occurs when an attacker tricks a web application into making unauthorized requests to internal or external resources on the server's behalf. This can allow an attacker to interact with internal system, potentially leading to data exposure or unauthorized action. Now let's take a look at this scenario. Imagine a server is like a helpful but naive assistant. You ask the assistant to fetch information for you and it happily goes to get that information. Now, if a tricky person, which is the attacker in our perspective here, is able to convince the assistant to fetch information not authorized for the attacker, like secret in a locked room, which is actually accessing internal resources, or even things from someone else's house in the case of external resources. So that is a bit of what is happening in an SSRF attack. The server unintentionally helps an attacker access things they shouldn't be able to access. Now we have 3 basic types of SSRF, which are the basic, the blind, and the semi-blind SSRF. So we are going to go through these 3 types of SSRF in just a minute. In basic SSRF, the attacker sends a crafted request from the vulnerable server to internal or external resources. For example, they might attempt to access files on the local system, internal services, or databases that are not intended to be publicly accessible. And this is one of the most easy types of the SSRF attack. Now we have the second type as the blind SSRF. In blind SSRF attack, the attacker doesn't directly see the response to the request. Instead, they may infer information about the internal network by measuring the time it takes for the server to respond or observing error messages. Now, the third one, which is the semi-blind SSRF, in this case, the attacker does not receive direct response in their browser or application. However, they rely on indirect clues like side channel information or observable effect within the application to determine the success or failure of their SSRF request. This might involve monitoring changes within the application behavior, response time, error messages, and other signs. So in order for us to be able to exploit an SSRF vulnerability, we need 2 basic prerequisites. The first is vulnerable input point and lack of input validation. So on the first one, which is the vulnerable input point, web application must have input fields susceptible to manipulation, such as URL or file upload functionalities. Secondly, the application should have inadequate input validation or effective sanitization mechanism, allowing an attacker to craft malicious requests. Now we're going to be taking a look at how does SSRF work. Now, this is basically in 4 stages. The first stage is identifying the vulnerable input. The attacker locates an input field within the application that can be manipulated to trigger server-side requests. This could be a URL parameter in a web form, an API endpoint, or request parameter input, such as the referrer. Now, secondly, manipulating the input. The attacker then imputes a malicious URL or other payload that causes the application to make unintended requests. This input could be a URL pointing to an internal server, a loopback address, or an external server under the attacker's control. Then thirdly, requesting unauthorized resources. The application server, unaware of the malicious input, make a request to the specified URL or resources. This request could target internal resources, sensitive services, or external system. And lastly, exploiting the response. Depending on the application behavior and the attacker's payload, the response from the malicious request may provide vulnerable information such as internal server data, system credentials and information, or pathway for further exploitation. Now, before we get into hacking into the command and control, as a disclaimer, hacking a command and control server is ethically unacceptable and illegal. Any suspected C2 activity should be reported to the appropriate incident response team for investigation and mitigation. This knowledge is provided solely for educational purpose only. Now let's dive into it. Detective Frost checked the C2 against known vulnerability, but none worked. He decided to give SSRF a shot. Now that we know how the SSRF work, can you help Detective Frost take down the C2 server? Now let's go into this in details. We have our requirements in connecting to this task. First of all, do I need to start the attack bus? Yes. Do I need to start the VM today? Yes. We have already started the virtual machine. Now we need our local machine to work with, but we're not going to be using the attack box. So we're going to be using OpenVPN to connect to this virtual machine. So let's do that quickly. I'm going to go to my local machine here and I'm going to open my terminal, and let's increase this a bit. Can maximize, and let's go to my OpenVPN folder. So I can connect sudo OpenVPN, my VPN configuration file, and this should connect us to the TryAcme network. Great, so we have the initialization sequence completed. So let's go back and see what next we're expected to do. So launch the virtual machine by clicking the Start Machine, which we have done already. At the top right of the task, wait for 1 to 2 minutes for the machine to load completely. You can access the C2 server by visiting the URL magridisecretc2.thm. But first, you need to add the host name in your OS or attack box. So basically what the host name file does is it kind of resolves an IP address to a domain name. So let's do that quickly. I'm going to grab this domain name, or first of all, let's grab the IP address, copy, and let's go to our attack box and let's fire up our Mozilla Firefox. All right, great. Let's make this bigger. Let's go with 120. And let's confirm that I don't have any proxy set up. I'll go to the settings and let's scroll down to the extreme end. We're going to select settings. Okay, great, no proxy. So I'll close this. Okay, so first of all, let me just put in the IP address. Okay, great. So this is the login panel for the command and control, but we want to be able to access this particular page using a domain name, which has already been given to us in the task. So what we are going to do is to open up another terminal. Then from here, we can quickly enlarge this. And let's fire up the sudo nano /etc/host. Okay, great. So let's go get the IP once more. I'm going to create a space for the host name. So I'm going to paste it in here. Then a space. Then let's grab our domain name, which is going to be magreedy secret c2.thm. Copy, and we're going to paste it in here. Okay, so let's save this. Ctrl X. I'll click on the Y key and enter. Now, if we verify this, let's go get the full link. I'm going to copy the link. And if we go into our Mozilla Firefox and we paste this, and this should load the command and control login panel. All right, great. So let's go into the TryAcme and see what next we're expected to do. So the first stage, which is identify the vulnerable input. Once we visit the URL for the command and control server, you will see that it is protected by a login panel. Maxkidi pen tester team have launched different types of automated and manual scan to gain access, but all in vain. For a target to be exploitable through SSRF, we need to use some vulnerable input to forge the request to the server. Sometimes, these requests can be found through scanning, viewing source code, or other documentation logs. And luckily for us, we have some API documentation on the command and control server. So let's go in there, and when we go to the access through API, and let's see what we got. Now we have some information regarding some questions and answers on this documentation. The first one is, how can I access the API to fetch data from an agent? And there's a description here. It says you just need to visit the endpoint, the machine IP, the getClient.php with a parameter URL pointing to this specific URL. For example, if your client IP is 10.10.10.10 and your machine is 10.10.10.10.20, the URL to fetch message.docs file from the client would be this particular URL here. And this is going to be useful in our attack. But before that, let's see what next we have on the second point here. The second question here is asking, how many requests can I make in 1 minute? And it says there's no limit on number of requests, and you can make as many requests as you want. The third question here is asking, is there any IP protocol whitelisting enabled? And it says currently we have not enabled any whitelisting, and you can use any protocol like HTTP, file, FTP, etc. And the last question is, what is the file name that contains all important credentials? And it says config.php, which is another valuable information. So what this is basically saying is, if we're able to use the SSRF to fetch the config file, we should be able to get the login credential of this particular command and control server. Now let's go into the TryAcme and see the next instruction that we have. So Maxkidi noticed a link to the documentation at the bottom of the page. Once we click on that URL, it directs us to the endpoint API. Now that we have some URL, we can try SSRF attack against them. So let's go back to what is actually being discussed here. And let's grab that URL here. I'm going to copy this, and let's just fire this up on a new tab and see what we got. Now you notice that the IP address used here is wrong IP address, which is not associated with what we are working on. So we need to modify this. I'm going to grab let's go ahead. Let's go to the host name. And I'm going to grab the host name, copy, and I'm going to paste here. Then let's just remove what we are fetching here and see what we have. So basically, this is just returning an empty page, but we're going to be appending some payload to this URL in just a minute. So let's scroll down and see what next we can do. So requesting the unauthorized resources, that is the next stage we are moving to. We can see that one of the endpoints, which is the get client data.php with the parameter URL, which is what we are having here, is pointing to an IP address of client or name of file that we want to access. Takes this URL as a parameter. So what that is what is going to take. So it's going to take this URL we submit as the parameter. If an infected agent URL is provided to it, it will fetch all the files from the infected agent. But what if we change the URL parameter to a different IP and try to access any other file? In this case, we are going to be looking for the index.php, which is the default page for the PHP script. And in order to do that, we're just going to append the file schema along with the path to the index.php, which is the /var/www/html/index.php. So let's grab that and we're going to append that to what we have here. And let's load that. Okay, do I have any connection issue? Let's go grab that again. Sorry, this one. I'm going to copy and let's add to the browser. And I'm going to paste this in here. Okay, cool. So what if I modify the domain? Does it make any effect? Let's go get that domain again. It's not supposed to throw error with the domain. Let's scroll down. Okay, cool. I'm going to grab this, copy, and we're going to head to the browser and just paste this in here. Okay, cool. So we have the domain working now. Now you see that we have been able to access the file or the script called index.php, and this is what it includes. Now let me just zoom in a little bit. Now we'll see that this is a PHP script trying to use the session start function here, and we're including the config.php, meaning that there is a file called config.php within this web server. Now we are checking if the form was actually submitted using a post request here, and we will be retrieving the submitted username and password using the post, as you can see it here. So username is being retrieved here and password is being retrieved here, and both of the username and password are saved inside the uname and pwd variable respectively. Now if you scroll down here, we also have a condition check which says if the uname, which is actually what we retrieved from the post request, and pwd, which is actually what we retrieved from the user's request also, is equals to username and password, which can be found inside the config.php file, meaning that the login to authenticate for this application is inside the config.php file. And what is going to happen if these two matches? If the uname matches the username and the pwd matches the password, what is going to happen is our session is going to be set to login, which is true, and the location was going to direct us to the dashboard of the application, which is a proof that we successfully logged into the application. And if this condition is not met, the else block is going to be executed, which is going to display the error message, invalid password, please try again. And that is why if you come to the command and control, let me just go back a little bit, and we just enter a random login credential, let's just say admin and admin, and you try to log in. Okay, what's happening? Let me just refresh. Let's just stick with the IP. So let's go again with admin and password admin, and I try to sign in. You see that we got invalid password, please try again, which is actually what is happening here in the else condition of this PHP script here. So what we are going to do now is try to read the config.php file. Let's go ahead and see what next. So we have been able to read the index.php file using SSRF. And this is a sample of the code we have behind on the server. Now, the file scheme, which we just used to access the index.php file, when used in a URL, typically references local file on a computer or file system. For example, a URL like file/path/to/any/file is often used to access file located on your local file system. Usually, an attacker can access sensitive files like the etc/password, and we're going to be trying to access these shortly, and connection string like the config.php and connection.php. So let's take a look and see if we're able to view this file mentioned here. Now, if we go to the machine here and we try to manipulate the file name, so let's just make this connection.php. Do we have any file like that? Did I get the name correctly? Yeah, connection.php. So there's no file called connection.php. Do we have let's change the path to etc/password. Good. Now we can see that we have here listed all the users within this application. Now, if we zoom in, you can see that, let's scroll down a bit. You can see that we have the Ubuntu user here, which has the ID 1000 and a group ID of 1000. We also have some other users like the EC2 instance and SSH and other one, but the most vital user here is the one from 1000 and above, which is what we're going to be sticking with as the legitimate user on this system. Now let's go back into our task here, and the next thing we want to be able to access is the config.php. Now, if I go copy the payload once again, let's just grab this part, copy, and let's head to our machine here, and we're going to replace the file path with index.php, and we're going to change the index to config.php. And you can see now that we have the credential to this command and control server. So let me just scroll in. So we have our username to be McGreedy, and we have our password also to be McGreedy with some special characters appended to it. Let's quickly get this credential to log in. So I'm going to copy and I'll paste this in here. Then let's go get our password, copy, and we're going to paste it in here, and we're going to log in. and this should give us access to the command and control. Great. So now we have access to the command and control environment, and let's try to see, can we zoom in a little bit? I'm beginning to see some flag here already, and we have some network, total number of computer we have 4 mobile devices and 65 files. We also have the connection going on. For example, we have Mark Skiddy's PC here. We have Mark Red, we have Mark Blue PC, and we have Mark Forensic PC. Now we can click on the menu and just perform some action, but it happens that these are just default link here, which does not actually perform any function. It just point back to the dashboard.php file. So let's go back to see what we can do. I'm going to scroll down. Now, before we talk about mitigations, let's answer some of the questions being asked in this task. And the first question says, is SSRF the process in which the attacker tricked the server into loading only external resources? Now, if you take a look at the definition of what an SSRF is, it's actually talking about both internal and external resources. So the server is making request to either an internal or an external resources. So look at the definition here. We have SSRF, or server-side request forgery, is a security vulnerability that occur when an attacker tricks a web application into making unauthorized requests to internal or external resources. In the case of this task, we are accessing an internal file, which is the config.php, in order to get our credential to log into the command and control server. So definitely the question here is going to be nay. So it does not only trick the attacker into loading only the external resources. So we're going to put nay and submit. So the next question says, what is the C2 version? And if we go back to the command and control dashboard and we scroll down, you can see that we have version 1.1 here. So I'm going to just add 1.1 and we're going to submit. What is the username for accessing the C2 panel? Now we can get this from the config file, which we got earlier. Let's grab is it the username or the password? Okay, username. So the username is McGreedy. Copy, and we're going to paste it in here. We're going to submit. The next question says, what is the flag value after accessing the C2 panel? We're going to go into the dashboard once more. Where do we have the dashboard? And when you scroll up, we have a flag just at the top here, which is can I highlight that? Is it possible? Okay, cool. I'm going to copy and let's paste it in here. What is the flag value after stopping the data exfiltration from Maskidi's computer? So we're expected to terminate the connection of the command and control with Maskidi's PC. So we're going to just go to the action. So I beg your pardon, go to remove and just deassociate the Maskidi PC from the command and control. Yes, remove it, and we get our final flag here. I'm going to copy and we're going to paste it in here and submit. Now, if you're enjoying this task, feel free to check out the SSRF room. I'm going to click on complete, and that is the end of this task. Now, there's much more that we can do using the SSRF vulnerability, and I'm just going to show you in a minute. Now, we can go into our attack box and go into our payload here, and we can try to view the Linux version for this particular server. So let's quickly modify our file path to proc/version, and this is going to give us the version of the Linux system. So the proc/version is a file that contains Linux kernel information, and we're able to identify that this machine is an AWS instance. And now what we can do is to see if you can obtain access to the cloud provider metadata of this AWS instance. Let's go back here a bit, and there's actually an article on that, and I'm going to just scroll to the obtain access to cloud provider metadata. So with SSRF, an attacker is able to read metadata of cloud provider that you use, be it AWS, Google Cloud, Azure, DigitalOcean, etc. This is usually done by using the private address that the provider listed in their documentation. And we have different examples of cloud service provider, and we're going to be choosing AWS since our instance is AWS, and the IP we're going to be using is the 169.254.169.254 for the AWS, and the payload we're going to be using for the metadata is this one. So we're using the target domain slash the endpoint, and we have the parameters and the value in here. So let's just copy in the value because that is just what we need. I'm going to copy, and let's head to our payload, and we're going to replace the file scheme with this AWS metadata URL. And you can see that we're able to provide the information relating to the metadata of this instance. And you can begin to explore these different directories. For example, let's just check one or two. We have security groups, we have services. Let's take a look at identity credentials. So we could possibly go into identity credentials, and let's see what we have there. So we have EC2. So I'm just going to append that to the URL, EC2. We have info and we have security credentials. Let's go into security credentials. Then we have EC2 instance slash EC2 instance. So, and you can see that we're able to, let me just zoom in. And you can see that we're able to extract the IAM access key ID, the secret access key, and the token for this particular web application. Okay, so that will be all for today in this video. Let's take a look at the different types of mitigation to SSRF attack. So when we scroll up, we have some mitigation measures, and the first one is employing strict input validation and sanitization to prevent malicious input. Secondly, using allow list to control which domain and IP the application can access. This is actually talking about whitelisting. And thirdly, applying network segmentation to restrict access to unauthorized resources. And lastly, following the principle of least privilege, granting minimum permission required for system operation. So guys, that will be all in this video. Please make sure you like, subscribe, and share, and I will see you in the next video.